Hello students, in this video we are going to discuss the problem based on the concept of absolute maxima and minima. In our last video we have discussed the problem based on the relative maxima and minima. So in case of relative maxima and minima we are given one function. We'll try to find out the extreme point where the function will attain its maximum value. So in case of absolute maxima and minima, so what is the difference here? Here in this case, instead of a function only, we are given one region also. So in this case, we want to find out the maxima and minima of the function relative to the given region. Okay. So let us try to understand that how can we find out the relative and the absolute maxima and minima of the function. So we'll consider one problem here to understand the concept. So the question is find the relative and the absolute maxima and minima of the function. The function is 4x square plus y square minus 2x plus 1 and the given region is 2x square plus y square is less than equal to 1. So basically we want to find out the relative maxima and minima as well as the absolute maxima and minima of the function in within the given region R. Here if we just look at the region here, region is 2x square plus y square is less than equal to 1. So before we are going to find out the solution of this problem, so firstly we need to find out that what is the given region here. Here the given region is here the given region is 2x square plus y square is less than equal to 1. So if we will try to express it, this region is of the type x square upon 1 by 2 plus y square upon 1 is less than equal to 1. So basically in this case the given region is an ellipse whose center is origin. Given region is ellipse whose center is origin and having major axis as y-axis and minor axis as x-axis. So basically the shape of the region is like this. So this is an ellipse where it is x upon root 1 upon root 2 square and y square upon 1 square. So it means that its x-axis is 1 by minus 1 by root 2 0. Here it is 1 by root 2 0 and this is 0 comma 1 and this is a point 0 comma minus 1. So this is the region. So we want to find out the relative as well as the absolute maxima and minima of the function. That means the point where which lie either inside or on the boundary of the given region. So firstly we'll try to see that is there any relative maxima and minima of the function or the absolute maxima and minima of the function. So the given function here f of xy is 4x square plus y square minus 2x plus 1. So for relative, firstly we'll try to find out relative maxima and minima. So the condition is we find out first order derivative with respect to x. This is 8x plus 0 minus 2 plus 0. That is 8x minus 2. We find out curly f upon curly y. This is equal to 0 plus 2y minus 0 plus 0. So its value is 2y only. So for extreme point, the condition is curly f upon curly x equal to 0, which will gives us the condition 8x minus 2 equal to 0. So from here we can get the value of x as 1 by 4 and curly f upon curly y equal to 0, which will gives us 2y equal to 0, hence it will gives us the point y equal to 0. So from here we can get the point here. So therefore the point is 1 by 4 0 xy. So firstly we want to see that either this point lie within this region. So here the value of x lies between minus 1 by root 2 to 1 by root 2. So if we say 1 upon root 2, This is approximately root 2 by 2, and we know that the value of root 2 is approximately 1.4142. So if I divide it with 2, its value is 0.7071, and 1 by 4 is approximately 0.25. So definitely this point lie inside this region on the x-axis. Okay, so it means that we can consider this point as the extreme point because this point falls completely inside the given region. Now to check that either it is a point of relative maxima and minima, we need to find out curly square f upon curly x square, second order derivative with respect to x. So it is curly by curly x of first order derivative, which is 8x minus 2, so which is 8. Definitely it is positive. Curly square f upon curly y square, this is curly by curly y of 2y, its value is 2, again it is positive. And curly square f upon curly x curly y, which is curly by curly x of 2y, which is 0. So already they are constant, so even if we calculate their value at the point 1 by 4 0, they are positive only. So what is the value of r? R is curly square f upon curly x square at the point 1 by 4 0. And because it is already constant, which is positive only, t is curly square f upon curly y square at the point 1 by 4 0. And again, because it is constant, it will remain same, its value is 2. And s, which is curly square f upon curly x curly y at the point 1 by 4 0. This is again 0, which is right. So what is the value of RT minus S square? 8 into 2 minus 0, so its value is 16, which is positive, and R and T, they are already positive. So what does it imply that? It means that 1 by 4 0 is a point of relative minimum. It's a point of relative minimum. Okay, so this is the point of relative minimum. Now after this we want to find out the absolute maxima and minima. That means for that what can we do? Apart from, because the relative minimum is, we'll try to identify that either there is any point which falls inside or as well as on the boundary of the region. Apart from this, sometime we know that the maxima or minima of the function lies on the boundary of the given region, right? So apart from the relative minima, absolute maximum minimum means that we need to check the nature of the function on the boundary of the given region as well as on the vertex point. So here we have a 5 vertex point, 0, minus 1, 0, 1, minus 1 by root 2 0, 1 by root 2 0, or 0 0. And apart from this, the boundary. The boundary means when 2x square plus y square is equal to 1. So firstly, we are going to check the maxima and minima on the boundary of the given region. On the boundary of the given region. Boundary of the given region, which is 2x square plus y square equal to 1. So therefore the intersection of the region with the given function f of xy, which is equal to, our function is 4x square plus y square minus 2x plus 1. So we are going to consider the point of intersection of the region and the surface. Okay, so we want to see that either we'll get a maxima or minima of the function on the boundary of the region. So there are two ways. Either I can get the value of x from here and substitute here, or the point of intersection, because it is easy to find out the value of y square from here, because in our function f of xy there is only a term y square here, so we can easily get the value of y square in term of x from here. So the point of intersection will be, if I consider y square equal to 1 minus 2x square and we substitute here, then what do we get? Let our function is g1x, which is f of x. We replace y with plus minus 1 upon square root of 2 minus x. This is 4x square plus 1 minus 2x square minus 2x plus 1, which is equal to 2x square minus 2x plus 2. Now because it is a function of x alone, so we name it as g1x. Now, what is the condition of maxima and minima for one variable? We have already discussed the concept of maxima and minima in one of our videos. So if we have a function of one variable, then firstly we find out first order derivative, put it equal to 0. We find out the extreme point, say x equal to a. Then we find out second order derivative. If second order derivative is positive, then we say that a is the point of minima. And if the second order derivative is less than 0, then we say that this is the point of maximum. So firstly we calculate g1 dash x, first order derivative with respect to x. So derivative is 4x minus 2. We put it equal to 0 for the extreme point. For extreme point, we'll put g1 dash x equal to 0. It will gives us 4x minus 2 equal to 0. So the value of x is 1 by 2. And now we calculate g1 double dash x, its value is 4, which is already positive. So even g1 double dash of 1 by 2, it is also 4, which is positive. So it means that x equal to 1 by 2 is the point of minima. And further, if x equal to 1 by 2, then the value of, that is the point, is 1 by 2 comma plus minus, because what is y square? It is 1 minus 2x square. So it is 1 minus 2 times 1 by 4. So 1 minus 1 by 2 is 1 by 2. So it is plus minus 1 by root 2. So because the value of y varies from minus 1 to 1, so it means that definitely this point lies inside the given, within the given region only, right? Basically, this point falls on the boundary of the given region. Okay, so because we have already considered the point of intersection of the surface with the boundary of the region. So this is the point here. Now, apart from this, so we need to, now we want to find out the absolute maximum and minimum. Absolute maximum and minimum means we are going to consider all the point, vertex point, as well as the relative maximum and minimum point, where the function attain its minimum value, that is called the absolute minima, where the function will attain its maximum value, that is called the absolute maximum, right? So for example, if we consider all the points, so the points are relative maximum point is, minimum point is 1 by 4 0. So this is 1 by 2 plus minus 1 upon root 2. Apart from this, we have a vertex point 0 plus minus 1 and plus minus 1 by root 2 0 and 0 0. So now we are going to check the value of the function at these points. So f of 1 by 4 0. This is equal to, because our function f of x y is 4x square plus y square minus 2x plus 1. 4x square plus y square minus 2x plus 1. So now let us check the value of the function at this point. So when x equal to 1 by 4, y is 0. Now its value comes out to be, this is 4 by 16 minus 1 by 2. So 1 by 4 minus 1 by 2 is minus 1 by 4. Now let us consider at the point f of 1 by 2 plus minus 1 by root 2. Because the value of y is always positive, so either I put plus 1 by root 2 or minus 1 by root 2, its value remains same. So 4 times 1 by 2 square plus 1 by 2 minus 2 times 1 by 2 plus 1. This is 4 by 4, 1 minus 1 plus 1. So its value is 3 by 2. So if we check f of 0 plus minus 1, this is 4 times 0 plus 1 minus 2 times 0 plus 1. 1 plus 1, its value is 2. So f of plus minus 1 by root 2 and 0. So in this case, we need to consider plus and minus separately. So I'm considering plus first. So its value is 4 times 1 by 2 plus 0 minus 2 times 1 upon root 2 plus 1. So it is 2 minus root 2 plus 1. So it is 3 minus root 2. So 3 minus root 2 means 1.4142. I consider this, then this value is 1.5858 approximately 1.585. And if I consider minus 1 upon root 2 0, then this is 4 into 1 by 2 plus 0 plus 2 into 1 upon root 2 plus 1. So this is 2 plus root 2 plus 1, so it is 3 plus root 2. Its value is 4.4142 approximately. And last but not the least is 0, 0. So its value is 0 plus 0 minus 0 plus 1, its value is 1. Now if we compare all the values, so this is the point where function attains its minimum value, and this is the point where the function attains its maximum value. So we can say that the function attains its absolute maxima at the point 1 by root 2 0, and the maximum value is 4.4142, and absolute minima at the point 1 by 40, and the minimum value is minus 1 by 4, that is minus 0.25. Okay, so what we need to do in case of relative and absolute maxima and minima, firstly, with the help of the concept of relative maxima and minima, means find out first order partial derivative, put them equal to 0, find out the point, but we need to ensure that that point should belongs to the given region only. So we are going to consider only those points which completely falls inside or at most on the boundary of the given region. Apart from this, we need to check the nature of the function on the boundary of the given curve, as well as we need to check the nature on the vertex point also. So where the function attains its maximum value, that is called the absolute maxima, and where the function attains its minimum value, that is called the absolute minimum. Okay, let us consider another problem. So in the previous problem, we have considered one curve, which is the single curve, right? Like ellipse is a single curve, but in this case, we are given a triangular region. So triangular region is a piecewise smooth. It is made up of piecewise smooth curves. So let me firstly draw the rough sketch of the region. Say this is x-axis, this is y-axis. So the given region is x equal to 0. X equal to 0 means y-axis. Is x equal to 0. Y equal to 0 means x-axis. And 2x plus y equal to 1 means when x equal to 0, y equal to 1. Where here the value of y is 1. And when y equal to 0, the value of x is 1 by 2. So this is the point 1 by 2, 0. And this is the point 0, comma 1. If I join them, so basically this is the triangular region we have. So we need to find out the absolute maxima and minima of the function within the given region, right? So let us firstly start with the relative maxima and minima. So in this case, our given function is 2x square plus y square minus 2x minus 2y minus 4. So firstly, we find out curly f upon curly x. This is 4x minus 2. This is 4x minus 2. And if we calculate curly f upon curly y, this is 2y minus 2. So for the extreme point, we are going to apply the condition curly f upon curly x equal to 0 means 4x minus 2 equal to 0. It means x equal to 1 by 2. And curly f upon curly y equal to 0 means 2y minus 2 equal to 0. So it will give us y equal to 1. So it implies that the point is 1 by 2 1. This is called the critical point or the stationary point basically. Critical point, stationary point or the extreme point. So now firstly we need to check that either this point lies within the given region or outside the given region. So we are given y equal to 1 and x equal to 1 by 2. So this is the point 1 by 2 0 and 1 by 2 1 is somewhere here. So basically this point lies outside the region because point 1 by 2 comma 1 lies outside the given region. Outside the given region. So we simply discard this point because we need to consider the relative and absolute maxima and minima within the given region only. So because this point lies outside the region, because our region is this triangular region, but the point 1 by 2 1 lies outside the region. So we simply discard this point, right? So now what is the next step? The next step is we want to find out the absolute maxima and minima of the given region. So we are going to check the nature of the function on the boundary of the given region. So your boundary is made up of three curves, x equal to 0, y equal to 0 and 2x plus y equal to 1. So let us consider this curve one by one. Along the curve, along the curve x equal to 0. So if we consider x equal to 0, so our function is f of 0 y. Means along this particular line, the value of x is 0. So our function is y square minus 2y minus 4. See, this is g1y because it is a function of y alone. Now we are going to check the condition of relative maxima and minima. So we find out first order derivative 2y minus 2 for extreme point. We'll put first order derivative equal to 0. So we'll use as the point 2y minus 2 equal to 0 means y equal to 1. So basically the point is x equal to 0 and y equal to 1. Along this line is 0 1. Right. Now we find out second order derivative. So g1 double dash y, this is equal to d by dy of g1y, which is 2y minus 2. So the derivative 2y minus 2 is 2, which is constant. And even if we replace it with y equal to 1, then its value remains 2, which is positive. Means that y equal to 1 is the point of minima. Or you can say that basically the point is 0 1 is the point of minima. Now we will consider along the curve y equal to 0. So along the curve y equal to 0, now your function is f of x 0. So f of x 0 means 2x square plus 0 minus 2x minus 4. So basically it is 2x square minus 2x minus 4. Say let this be equal to k1x. So firstly we find out first order derivative, this is 4x minus 2e. And for extreme point we'll put k1 dash x equal to 0. Means 4x minus 2 equal to 0, the value of x is 1 by 2. It means that the point is 1 by 2 comma 0, because along this line y equal to 0, the point is 1 by 2 0. So now we calculate second order derivative. k double k1 double dash x is 4, so its value will remain same for x equal to 1 by 2. So again it is positive, it means that 1 by 2 is the point of minima. Now we are considering along the curve, along the line 2x plus y equal to 1. 2x plus y equal to 1. So we can find out the value of y as 1 minus 2x. It means f of x 1 minus 2x. We are going to replace y with 1 minus 2x. So basically the point of intersection of the given function and the region. So it will give us 2x square plus y square means 1 minus 2x whole square minus 2x minus 2y. Y is 1 minus 2x minus 4. So your function is 2x square plus 1 plus 4x square minus 4x minus 2x minus 2 plus 4x minus 4. So here 4x and 4x get cancelled out. So this is 1 and this is minus 6. So we get, let this be k2x. So it is equal to 6x square minus 2x. 1 minus 6 is minus 5. So again for extreme point, firstly we find out first order derivative. It is 12x minus 2. So for extreme point, we put k2 dash x equal to 0. 12x minus 2 equal to 0 means x equal to 1 by 6. So if x equal to 1 by 6, then what is the value of y? So x equal to 1 by 6, your curve is y equal to 1 minus 2x. So it is 1 minus 2 times 1 by 6. So its value is 1 minus 1 by 3, that is 2 by 3. So therefore the point is, critical point is 1 by 6 and 2 by 3, which lies on the line y equal to 1 minus 2x. Now we find out second order derivative. So k2 double dash x. So it is d by dx of first order derivative, which is 12x minus 2, which is 12. And even if we replace it with x equal to 1 by 6, its value remain positive only. So it means that 1 by 6, 2 by 3 is the point of minima. So basically we'll get 3 point of minima. One is 0 comma 1, which is also the one of the vertex point. 0 comma 1 is the vertex point. Another one is 1 by 2 0, which is another vertex point. This is another vertex point 1 by 2 0. So we left with one more point, that is 0 0, and we have the point 1 by 6 2 by 3. So let us see that where the function attain its absolute maxima and minimum. So basically the points are 0 comma 1, 1 by 2 0, 1 by 6 2 by 3, and the vertex point 0 0. So at the point 0 1, what is f of 0 1? So your function is f of x y is equal to 2x square plus y square, 2x square plus y square minus 2x minus 2y minus 4. So here put x equal to 0 and y equal to 1. Minus 2 times 0 minus 2 times 1 minus 4. So 1 minus 6 is minus 5. And if we consider the value of the function at the point 1 by 2 0, so this is 2 into 1 by 4 plus 0, 2 times 1 by 2 minus 0 minus 4. So 1 by 2 minus 1 minus 4. So this is minus 1 by 2. So it is 9 by 2 with negative sign. And if I consider f of 0 0, so its value is 0 plus 0 minus 0 minus 0 minus 4. Its value is minus 4. And last one is 1 by 6, 2 by 3. This is 2 times 1 by 36. 1 4 by 9. 2 times 1 by 6. 2 times 2 by 3 minus 4. So 1 by 18. 4 by 9. 1 by 3. 4 by 3 minus 4. So if I take the LCM of say 18, so 1 plus 8 minus 6 minus 24 minus 72. So its value comes out to be 19 105 105 plus 9 minus 105 plus 9. So basically it is minus 96 by 18. So its value comes out to be minus 5 point. 18 5 का 96, 18 3 का 54, 63, so on. So if we compare all these values, so here this is the point minus 5, this is minus 4.5, this is minus 4, and this is minus 5.33. So although all these points are point of relative minima only, so this is the point where the function attained its minimum value, so it means that it has the absolute minima at the point 1 by 6, 2 by 3. So this is the absolute minima of the function. Okay. Okay. Now let us consider another problem. So this time we want to find out the smallest and the largest value of the function on the line. So again, if we check the region here, this is x-axis, this is y-axis, this is the line y equal to 0, this is the line x equal to 0, and x plus 2y means when x equal to 0, y equal to 1, and when y equal to 0, x equal to 2. So it means that again, this is a triangular region with these vertex points. So what is our function here? A function f of x y is x into y. Firstly, we find out relative maxima or minima. Curly f upon curly x is y. Curly f upon curly y is x. So for extreme point, we put curly f upon curly x equal to 0 means y equal to 0. Curly f upon curly y equal to 0 means x equal to 0. So the point is 0 0. But in this case, second order derivative is 0. Second order derivative with respect to y is also 0. And second order derivative with respect to x, y is also 0. Means r is 0, t is 0, and s is 0. So when r and t are 0, we are not able to conclude anything because if you remember while discussing the formula, so we have discussed the condition that we have multiply and divide by r. It means that with the help of that formula, we are not able to conclude that either it is a point of relative maximum or minimum, right? So now what can we do? We are going to check the nature of the function on the boundary of this particular given region. Although 0 0 is one of the vertex point also. So Along the line x equal to 0, f of xy is xy. When x equal to 0, its value is 0. It is a 0 function. And along the line y equal to 0, again f of x 0, its value is again 0. Now along the line 2x plus y equal to 2, sorry, x plus 2y equal to 2. X plus 2y equal to 2. So say we calculate the value of x as 2 minus 2y. So the point of intersection is f of 2 minus 2y comma y. This is 2 minus 2y into y. It is 2y minus 2y square. So firstly, say we name it as gy as 2y minus y square. So firstly we calculate first order derivative. This is 2 minus 2y. Then we put calculate second order derivative, which is minus 2. And for extreme point, if we put g dash y equal to 0, it means 2 minus 2y equal to 0. The value of y is 1. And if y equal to 1, x is 2 minus 2y. So this is 2 minus 2, it is 0. So therefore the point is 0, 1. And g double dash of 1 is minus 2. It means that 0, 1 is a point of maxima. So x is 2 minus 2y, 2 minus 4y. 2 minus, okay, basically it is 4y. So the point is 1 by 2. So when I put x y equal to 1 by 2, its value is 1. 1 comma 1 by 2. So because this point lies on this particular line only, so it means that this is the point where the function retains its maximum value. So what are the points? So the points are 0 comma 1, 1 by 2 comma 0, 0, 0, and 1 comma 1 by 2. So f of 1, 1 by 2, this is equal to x into y, that is 1 by 2. And f of 0 comma 1 is 0, f of 1 by 2 comma 0 is 0, f of 0 0 is also 0. So this is the point where the function attains its maximum value and the minimum value is 0. So the maximum value of the function is 1 by 2. This is the absolute maxima, and the minimum value is 0. These are the point where the function attains its absolute minimum. So this is the answer of this problem. Okay. So this is the concept we are doing for absolute maximum and minima. That means apart from the relative maximum and minima, that means we need to check the condition of relative maximum and minima, but we need to ensure that the point should lie inside the given region only. And on the basis of that, we are going to check the condition of relative maximum and minima. If the point lies outside the given region, then we can directly exclude that point. Apart from this, we need to check the nature of the function on the boundary of the given region as well as on the vertex point also. So along all the line as well as the this line, we need to check the nature of the function where the function attains its maximum value, that point, or the minimum value, that point, as well as the critical point. And then we need to check where the function attains its maximum value, that is the point of absolute maxima, and the point where function attains its minimum value, that is called the absolute minimum. This is how we are going to tackle the problems of absolute maxima and minima. So we have tried to consider the different kind of problems where we are given a single curve or we are given the piecewise smooth curve, we'll try to include that kind of arms here also, right? So you can revise problem based on this part. Still, if you find out any doubt or any query, you can post your query in the comment box. I'll try to provide you the solution of the same. Thank you and have a nice day.